Hello, am I audible to all? Just wait, I'm sharing screen. Hello. So good afternoon, everyone. So today we'll take some revision and we'll discuss the remaining 2 points. Okay. So our chapter is equipment protection. In this chapter, we are studying here the transformer protection, generator protection, induction, and bus bar protection. Out of this, we completed this transformer protection. Generator protection is going on, and two remaining points are induction motor protection and bus bar protection. Okay. So in that, we have seen first the transformer protection. So in transformer protection, full screen is not visible, I think. Wait, I'll share that again. Okay, I think there is some problem in sharing full screen. So you can just maximize the screen uh, of your mobile. Okay. So in transformer protection, we have seen the different types of faults. Okay, so which are the faults in transformer? You can just imagine the faults, and you first see the construction of that transformer. Primary winding, secondary winding, and simply core is there. Okay, so there are some internal faults and external faults. So whatever be the internal faults occurring, that are occurring in the winding and in the core. Okay, and external faults means some suppose cooling system problem is there, or some external or matters are there, then that fault is occurring. Okay, then overheating means sometimes what happens, the load on transformer increases, and if that load increases, it will heat the transformer. Okay, because the current get increased there. Then also there is sometimes there is short circuits. Okay, means if we are considering the three-phase transformer, then there are such faults, that is line to line to ground faults, etc. So if such faults occurs, okay, that is also called it also overheats the transformer, and also failure of the cooling system. Okay, so for transformers, we are cooling that transformer by using different ways, that is the air or oil. We are putting our transformer uh, in the tank which is filled with oil. Okay, all of you know that. So if there is problem in that cooling system, then also your transformer will overheat. So these are some types of the faults occurring in the transformer. Just like the winding faults means if the insulation is weak, or if there is any breakdown in the insulation, then open circuits of the phases. Then external faults means the mechanical faults, right? Then overfluxing we have seen in detail. Then earth faults means or simply the line to ground faults or double line to ground faults. Okay, then phase faults, interturner faults, core faults. Okay, core means if the transformer core sometimes it get deteriorated, or if any problem in the transformer core, so that is also causing the fault. Then tank faults and cooling failure, then tap changer faults. Okay, means if the tap changing transformers we are using, that time such faults are occurring. Then next point we have seen is the overcurrent protection of transformer by using this phase and ground relays. So we know that different types of faults are occurring. That is when it is a phase-to-phase fault, or when it is the line to ground or single line, double line to ground fault. That time, what will happen? The current will be more. Okay, if there is a short circuit, the current increases. It is different for the earth fault and for the phase fault. Okay, so in which fault current is more? In which fault current is more? Yes, in which fault current is more? Phase to phase, yeah, earth fault? Yes, anyone? Phase to phase, yeah, earth fault?
Face to face.
Correct, correct. In phase to phase fault, the current is more. Okay, and in ground fault, the current is less. Okay, so means here also we are using different relays. We have seen the overcurrent relays, right? So here we are setting the value for such faults. In numerical, we have seen the practical of numerical overcurrent relay. In that, what we there is also earth fault and phase fault setting. Okay, so means for phase to phase fault, we can set the value of current, and for earth fault, as these currents are lower in value, we can set the value there. Okay, so in these relays, that current value, that is the pickup current value, is set in that relay, and these relays are protecting your transformer from the overcurrent. Okay, after that, we have seen the percentage differential protection of transformer. Percentage differential protection means what? This differential protection means actually in when we are considering any type of relay, we are using the differential coil and operating coil, right? Now, differential coil is there and operating coil is there. Now, what actually happens there? What actually happens there? So that when the current is flowing through that operating coil, your relay starts operating. Okay, म्हणजे रिस्ट्रेनिंग कॉइल मधून पण करंट फ्लो होतो आणि ऑपरेटिंग कॉइल मधून पण करंट फ्लो होतो. पण रिस्ट्रेनिंग कॉइल काय करते, तर तो आर्म जो आहे तो होल्ड करून ठेवते. मग जेव्हा ऑपरेटिंग कॉइल मधून करंट जास्त फ्लो होतो, त्यावेळी तो जो आर्म आहे तो ती ऑपरेटिंग कॉइल काय करते, अट्रॅक्ट करते. दॅट टाइम सुरेश कुमार, जस्ट टर्न ऑफ युअर व्हिडिओ. Okay, so when this operating coil current increases, what will happen? It will attract that arm so that the contacts of relay get closed. Actually, the relay contacts are open, and after occurrence of fault, these contacts get closed. Okay, so when the difference of that current is flowing through that relay coil, then only this relay is operating. That's why it is called the differential protection. Okay, so here the this is important diagram. So here R, Y and B phases are there. Okay, this is your primary side of the transformer. This is secondary side. This primary is connected in star, and this secondary side is connected in delta. Okay, to both sides of this transformer, means primary and secondary, there are two circuit breakers, and this CTs are connected. Okay, to the primary and to the secondary also. Means what? How actually this transformer is connected? From somewhere, from your generating station, supply is coming. Okay, it is either step up or down by using the transformer, and again that will be supplied to the load. Okay, so in this way this transformer is working. Means to its primary, as this primary winding of transformer is star connected, So the primary winding of CT means current transformer. Why the current transformer is used? We have to measure the value of current. Okay, we have to measure the value of current through that transmission lines. Okay, that's why we are using this current transformer, because these current transformers can step down that current to the measurable value. Okay, to the measurable value. So we are using this current transformer. So now this current transformer is connected in which star या delta? Star या delta? स्क्रीन तुम्हाला हे होत नाहीये काय?
मॅम स्क्रीनच दिसत नाही.
दिसत नाही.
दिसत नाहीये.
दिसते पण युनिट कंटेंट्स दिसतात ओनली.
मी ते हे केलंय, तेच मला आता दिसलं. एकच मिनिट. तर मी स्टॉप करते शेअरिंग, परत एकदा स्क्रीन शेअर करते. ओके, आता दिसतंय ना? ओके, दिसतंय आता.
हा मॅम.
आणि सांगत जावा, कारण मी बोलण्याच्या ह्याच्यात लक्ष नाही दिलं. ओके, so here you can see the transformer. This transformer's primary is connected in star and secondary is connected in delta. Okay, so to both sides of this transformer, circuit breakers are there. 2 circuit breakers are there. Okay, now to the primary, actually primary of transformer is connected in star, so we are connecting this CT in delta. Okay, तो जो फेज डिफरन्स आहे तो ऑप्टेन करण्यासाठी काय करतो आपण, तर जर ट्रान्सफॉर्मरची प्रायमरी स्टार मध्ये असेल तर CT सेकंडरी डेल्टा मध्ये कनेक्ट करणार. जर डेल्टा ट्रान्सफॉर्मरची सेकंडरी डेल्टा आहे तर CT सेकंडरी कशाला असणार आहे, स्टार कनेक्टेड. ओके, means what actually happens, whatever be the current before given to whatever be the current flowing through that transmission line, okay, or these phases before supplying to the transformer, okay, that is checked here. Okay, and we are again checking the current which is flowing through these RY and B phases when it is coming from the transformer. Means just tell me if any fault is occurred. Okay, if any fault is occurred in this transformer only, then what will happen? Suppose there is interturn fault, means that transformer get overheated. Okay, or if any line to line or any line to ground fault, means face to earth fault is occurred, then the current get increased here. So when that current increases, what will happen? This CT, okay, which is connected to the primary side of transformer, so the current will be checked by that CTs also, and this secondary side, okay, means the secondary side of transformer, there is also CT, so that current will be checked here. In that current will flow through this restraining coil. Okay, through this restraining coil, means actually there is half section of this restraining coil through which here actually up to this point the current this current is flowing, and here this current is flowing. So suppose I'm considering this current is I1 and here the current flowing is I2. Now what will happen if there is any difference between the current? Actually I1 should be equal to I2, right ना? म्हणजे जो करंट आपण ट्रान्सफॉर्मरच्या प्रायमरीला दिला आहे, जो काही करंट असेल तर तोच सप्लाय तुमच्या सेकंडरीला पण पाहिजे, राईट ना? मग जर त्याच्यामध्ये काहीतरी डिफरन्स असेल तर काय झालंय, that is nothing but the fault. Okay, you don't know what type or which type of fault is actually occurred there, but if these two currents are not equal, it means that the fault is occurred. Okay, and that difference of current is flowing through this through this operating coil. okay, through this operating coil. Okay, so when this current is flowing through the operating coil, your relay will operate. So for all the three phases, for R phase, okay, for Y phase, and for B phase, okay, for B phase, all three phases are connected to this restraining coil, and then these are connected to the operating coil. Okay, isn't it? So that's why it is called the differential relay. Differential relay means the difference of current is flowing through the overcurrent, through the operating coil. Okay. Then we have seen the harmonic restraint differential relay. Harmonic restraint differential relay means what? What actually happens when we are considering that that there is any fault is occurred. So that time what happens when any fault occurs, whatever be the harmonics produced, okay, means our wave get distorted here. Our wave get distorted here, right? That time whatever be the harmonics produced, these are having fundamental values. These are the fundamental. These are fundamental. Okay. But sometimes the harmonics are of more order. Okay, means third, fifth, seventh order, etc. So for that purpose, we have to use this harmonic restraint differential relay. So here we are using the filter. We are using here the filter, that is XC and XL coils are connected here. Okay, and by using this rectifier unit and these filters, we are removing all the harmonics. Okay, so that is the harmonic restraint differential relay. Then next is the Buchholz relay. This is for incipient fault. Incipient means these are the slowly developing faults in the transformers. So this Buchholz relay is important here. It can be asked in examination also. So it is a gas actuated relay mainly. So when any fault will occur in the transformer, okay, if any fault will occur in the transformer, what happens? Some gases are produced. Okay, some gases are produced there, and this relay gets operated there. Okay, and actually it is giving the alarm. Okay, it is giving the alarm when that fault is occurred. Okay, so that this Buchholz relay is connected in between your transformer tank and the conservator. Okay, and the conservator. So here this is transformer tank, Buchholz relay is there, conservator is there. So if any fault will occur, it will produce the gases. Okay, and these gases will actuate this Buchholz relay. Okay. Then next point is protection against overfluxing. Overfluxing, we have discussed that when we are giving extra excitation, when the transformer core is saturated. Okay, म्हणजे ट्रान्सफॉर्मरचं कोर सॅच्युरेट झालं तरी पण आपण काय करतो, तरी पण सप्लाय देतो. मग त्यावेळी काय होतं, तर ते कोर डॅमेज होऊ शकतं. ओके, सो दॅट इज कॉल्ड द overfluxing. So we have to again the relay is used for its protection. Okay, then generator protection we have seen. So there are also different types of faults occurring in this generator, and some abnormal why these faults are occurred, because of this overload, under voltage, loss, or insufficient excitation. म्हणजे जनरेटरला एक्सायटेशन म्हणजे इनपुट भेटला नाही तर, देन अंडर अँड ओव्हर फ्रिक्वेन्सी. ओके, देन अनबॅलन्स करंट, out of step means loss of synchronism. So if the synchronism of this generator fails, then that is called the out of step, and loss of prime mover. Okay, then okay, then next point is the generator protection. So here There are again different types of faults occurring, that is the earth fault and phase fault. So this is the general scheme for the earth fault protection. So we will see this in detail. So actually in transmission system, how this generator is connected is given here. So we have seen the differential protection of the alternators also. So it is also called the Morse-Price circulating current scheme. Okay, remember the names, Morse-Price circulating current scheme. So here we have seen again it is same. We can see this diagram and whatever we have seen for the transformer protection, both are same. Only what is the difference? Here in transformer, in between this line, we are using the transformer. Means we are protecting the transformer here. And here we are protecting this alternator. Okay. Now, this is the stator winding of this alternator is shown. We are protecting this generator or alternator. So the two types of faults are shown here. That is the phase to ground fault. Okay. Means this fault is occurring in R phase and phase to phase fault. Okay. And that fault is occurring between the Y and B phases. Okay. Then here also the CTs are connected. This is connected in star, and this second side CT is also connected in star. And these two phases means R phase is connected to R, Y to Y, and B to B. All are connected here, and to each phase there is a relay. Okay, these relays are connected with each phase, and this side is grounded here. Okay, grounded here also. The CTs are grounded here. You can see all the neutral points are connected here, neutral point, and it is grounded for both side CTs. Okay, and when that fault will occur, suppose that earth fault is occurred in R phase, then current through that phase will increase. That time this relay, now this R phase relay, this relay R1 will operate when the earth fault will occur. If there is phase to phase fault, means if the fault is occurring between Y and B phases, that is phase to phase fault, then these two relays remaining, that is Y and B phase relays, that is R2 and R3 will operate that time. Okay, and when these relays will operate, these relays will give signal to the circuit breaker to open its contacts. Okay, म्हणजे जर आर फेज मध्ये समजा फॉल्ट झाला, okay, the fault is occurring only in R phase, then only this circuit breaker will operate and it will open the contacts of this phase. Okay, similarly for these two relays also, means for Y and B phases also. Okay, then we have also seen yesterday the protection of generator due to unbalanced loading. Okay, due to unbalanced loading. Unbalanced loading means what? If there is imbalance between the load, means suppose the load whatever be म्हणजे लोड कपॅसिटी दिलेली असते. ओके, म्हणजे एवढा एवढा याचा लोड तुम्ही it can bear, okay, or it can sustain that load. So that capacity is given, but if we load any generator more than that, then what happens? The current flowing through that generator increases. We know that when load increases, the current also increases. So what happens actually when that current will increase? Okay, when that current will increase, means it get changed, means there is imbalance, okay, between the current. Okay, means the angle between the two currents is actually 120 degree, but it becomes less or more means that system is not balanced. When we are saying that the system is balanced, when the angle is of 120 degree only, and the current flowing through the neutral wire is equal to 0. Okay, is equal to 0. Then if the system becomes unbalanced, then what will happen? Can anyone tell me? Tell me. Can current flow through the neutral wire if system becomes unbalanced? Yes. Yes, if system becomes unbalanced, then whether current is flowing through neutral or not, करंट फ्लो होतो का न्यूट्रल मधून सिस्टम अनबॅलन्स झाल्यावर? किरण किरण पूनम yes 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 anyone what will be
Madam.
huh? yes yes Kiran, if the system is unbalanced, just tell me, is there any current flowing through the neutral wire? No. Yes or no? Okay, remember current will flow through the neutral wire. Okay, if the angle is exact 120 degree, means the system is balanced. That time current flowing through the neutral is equal to 0. But if the system becomes unbalanced, okay, means the angle is less or more than 120 degree. That time this is not equal to 0. The current flowing through the neutral is not equal to 0, means current will flow through the neutral, right na? Earthing कशासाठी करतात? Why we are doing earthing? Means if any fault will occur, that fault current will flow through the neutral, right na? That fault current will flow through the neutral towards the earth, right? That's why we are doing the earthing, right na? So means your system becomes unbalanced here. Okay, so for that purpose, means if there is unbalanced loading, for that purpose we are using this negative sequence filter. We are using this negative sequence filter, and here overcurrent relay is also used. Okay, the same stator winding is there, generator for the generator protection, everything is same here, only we are using for the protection against this unbalanced loading, we are using the negative sequence filter and overcurrent relay. Okay, why negative sequence filter? Because here this when we are considering such faults are occurring, that time the negative sequence components get created there. All of you know the positive sequence, zero sequence components for current are I0, right na? For positive the suffix is 1 or 2. Positive sequence, negative sequence components. Okay, so that you should know there. Okay, so that negative sequence components are there, so we have to use filter. Then next point we have seen is the rotor overheating. So when this rotor overheating happens in case of the large generators. Okay, means such type of protection is provided for the large generators, means actually the temperature is increased. Okay, the temperature is in, when the temperature get increased in the rotor, that time we are using the relay, and we are measuring that temperature by considering the resistance here. Okay, by considering the resistance, actually your voltage coil is there, current coil is there, and this voltage coil is nothing but your operating coil, and this current coil is nothing but your restraining coil. Okay, so means whatever be the current and voltages are measured, and this resistance is calculated, and from that we can find the temperature. Okay, then excitation failure. Okay, means whatever supply we are giving, so if that supply get failed, then whether your generator is working or not. Okay, means if the excitation fails, your generator is working or not. So for some cases, that generator is working, but when we are using for small stations, okay, the generators are not working. Means if that excitation get failed there. Okay, so if there is failure of such a excitation, that time directional distance type of relays are used. Directional distance type of relays are used here. Then protection against motoring. So this is the new point here which we are going to see now. Protection against motoring. Motoring means what? Can anyone tell me? Actually, we are using here generators. We are protecting here generators. Then what is mean by motoring? Motoring means what? Motoring means motoring mode of this generator means whatever be the supply we are giving, okay, that is coming reverse. That is coming reverse. Okay, means in generating mode, what is the function of generator? It is just converting the mechanical energy into electrical energy. So when it comes in the motoring mode means reverse condition, means it starts converting the electrical energy into mechanical. Okay, means it starts acting as a motor. That is nothing but the motoring of the generator. Okay, so in a generator there is a prime mover. We know that prime mover is there, excitation field is there, and that is that generator is supplying to the grid system. Okay, so here in this generator, when we are considering the prime mover, which is a steam turbine prime mover, suppose a steam turbine is there, and that is supplying the mechanical power to the generator. So this mechanical power is converted into the electrical power, and it is delivered to the electrical system. Okay, so this is generator. All of you already know that what generator does, right? So the causes of generator motoring means why actually this mode is coming. Okay, what are the causes of this generator motoring? So this is a condition. This generator motoring is a condition that happens when the prime mover cannot supply enough power to the generator, okay, to account for the load demand on the generator. So what happens? The prime mover is not supplying the the required power. Okay, म्हणजे लोड त्या जनरेटरवरचा लोड जास्त आहे. ओके, त्या जनरेटरचा लोड जास्त आहे, पण त्या जनरेटरची तेवढी कपॅसिटी नाहीये की तेवढी इलेक्ट्रिसिटी जनरेट करण्याची. ओके, मग ते कशामुळे? तर प्राइम मूव्हर कडून मिळणारा सप्लायच नाही. म्हणजे जनरेटरसाठी इनपुट काय आहे आपला? तर mechanical energy. We are giving mechanical energy, right, as an input. So whatever be the input is taken from that steam turbine is less, or it is not sufficient to supply that much load. Okay, that much load. Now the electrical system needs to make up for this loss in prime mover input power. Then what we have to do? So this electrical system needs to make up for this loss. Okay, means हा लॉस काय करावा लागतो तर भरून काढावा लागतो. म्हणजे जेवढं आपल्याला लोड आहे तेवढा जनरेटरनी प्रोड्यूस करणं एक्सपेक्टेड आहे. पण जर समजा प्राईम मूवर तेवढं प्रोड्यूस करत नसेल तर काय करावं लागतं आपल्याला काहीतरी सप्लिमेंटरी द्यावं लागतं. ओके, सो when this happens, the generator begins to act like a motor. Okay, otherwise this generator will start like a motor by absorbing real power from the electrical system. As I told you, what will happen, this generator will act as a motor. Okay, म्हणजे काय करणार, रिव्हर्स होणार. म्हणजे लोड साइडनेच सप्लाय घेणार आणि तोच output for prime mover. It will give an output to the prime mover. Okay, so in this way the reverse condition may happen there. So this is to make up for the supplied power deficiency by speeding up the prime mover. Okay, so for this purpose we have to do something so that your prime mover will supply to the generator. Okay, the next point is the consequences of this generator motoring. Okay, means what? So when your generator goes in the motoring state. Okay, so this protection against generator motoring is designed to protect the prime mover as opposed to the generator. Okay, means it is used to protect the prime mover. Then motoring does not necessarily harm your generator, but it will cause the prime mover to overheat. Okay, actually when this motoring mode is coming, that time there is no any effect or it is not harmful to the generator, but your prime mover get overheated when there is a motoring mode. Okay, actually this is just like you may have studied in power systems about म्हणजे एखादं लोड जर इन्क्रीज झाला तर लोड इन्क्रीज झाल्यानंतर पॉवर सिस्टीम मध्ये पण कसे इफेक्ट्स होतात. मीन्स वी हॅव टू इंजेक्ट समथिंग, राईट ना, वी हॅव टू इंजेक्ट समथिंग. मीन्स देर इज active power, reactive power. Active means it is the real power, reactive power, and what we are doing. So if the load increases, we have to inject some active power, right na? So if that load is less, we have to give inject their reactive power, right? So झाले का नाही माहित नाही तुम्हाला. I think that is in facts. Okay, in next semester it is. Okay, so you have to inject their active and reactive powers. So here the same concept is here only. So this motoring does not necessarily harm your generator, but it will cause the prime mover to overheat. Then field excitation should remain the same as before. Okay, means whatever we are giving supply to the field winding. Okay, that field winding excitation should remain same as before generator motoring occurs. So the same reactive power will be flowing from the generator. Okay, means if we keep this field excitation same, then same reactive power will flow from the generator. Otherwise we have seen if there is any fault, then what happens? If there is any fault, what happens? The reactive power increases to 2 to 3 times. Already there is reactive power which is produced by generator, and if that fault will occur, again your reactive power will increase by 2 to 3 times. Then it is not the desirable. It is not desirable. That's why when this motoring is occurring, before that we have to give the field excitation same. Okay, so with generator motoring, real power flows into the generator and reactive power flows into and out of the generator. Okay, so when we are keeping this excitation, field excitation constant, that time what happens? Then real power means which power? Real means which power? Active or reactive? Real power means, correct, it is active power. So that active power flows into the generator and your reactive power will flow into and outside of the generator. Okay, so this will happen when the motoring will be there. Okay, then how to protect this generator against the motoring mode? So this generator motoring protection can be provided by limit switches. Okay, means we are using the switches there. And if you need a large number of these devices, add a reverse power relay. So we are using the रिव्हर्स पॉवर रिलेज, म्हणजे जी पॉवर रिव्हर्स येते. ओके, म्हणजे जनरेटरची जी मोटर तुमची ऍक्टिव्ह मोटर म्हणून जे ऍक्टिव्ह होते ते रिव्हर्स पॉवर फ्लो will be detected by that relay. Okay, and that relay will operate there. So these reverse power relays are common in diesel generators where unburned fuel is both an explosion hazard and fire hazards. Okay, so this type of relay means reverse power relays are used in diesel generators. Okay, म्हणजे motoring, if there is a motoring mode, that time what we are doing, we are simply connecting a reverse power relay. Okay, or we are connecting the limit switches there. Okay, so that simply we can open these switches and stop the motoring of the generator. Okay, now I hope everybody got this, the generator motoring. Okay, the next point is the generator transformer unit protection. Okay, generator transformer unit protection. So here actually we have seen the separate protection scheme for the generator, separate protection scheme for the transformer also, right na? Same diagrams. Okay, म्हणजे दोन्ही साइडला CTs आहेत and to the lower side there are relays, but here we and there we in the differential protection, and here for there you have to protect the transformer once and then generator ones, means we are showing only the field windings there, that is sorry, the stator windings there. Okay, for the generators or for alternators. Now this is generator transformer unit protection. Okay, means when we are considering a generating station, that time generator is also there and transformer is also there. So which type of transformer will be available at the generator side, at the generating station? Step up या step down? Yes, step up या step down?
Step up.
Correct.
Step up.
Wait for a minute. Hello. Huh. So, generator transformer unit protection. Unit protection means we are just combining these two units, that is generators and transformers, and to its primary and secondary again we are connecting the CTs, that is current transformers. Okay. So here its diagram is there. So you can see here there is a generator. Okay, this is generator is there. Then transformer is there. Okay, so this transformer is connected in delta and primary, delta and star. So its primary is connected in delta and its secondary is connected in star. The symbols are shown here instead of windings. Okay, so can anyone tell me, if the primary of the transformer is connected in delta, how we can connect the CTs in delta star? How we have to connect the CTs in delta star? Yes. How to connect the CTs? Anyone? Yes, anyone? Please, fastly tell me. The primary is connected in delta, right? So what we have seen in the transformer protection and in generator protection, or in transformer protection only, previous one, if the primary is connected in delta, your CT should be connected in star, right? It should be up